Hello and welcome. My name is Üstün Özgür and I'm a JavaScript developer from Turkey visiting Barcelona for March. And today the topic of the talk will be EcmaScript 6. So let's start with the distinction between EcmaScript and JavaScript. When JavaScript was first implemented at Netscape, it was just a programming language. Later on, Microsoft implemented it as JavaScript in its own browser, and then a need for a standard came. And therefore, a specification was created in the name of EcmaScript. And this EcmaScript is basically a documentation which each implementation has to conform to. So it's not an implementation, it is just a specification of what needs to be implemented for a conforming implementation. So it is governed by the TC39 Technical Committee in ECMA Standards Group. And we will first go over the different versions of EcmaScript. The most significant version, the first most significant version was EcmaScript 3, which was released in 1999. And then within the technical committee, some people tried to get more ambitious features into the project itself. Unfortunately, this created some confusion within the committee members and some disagreements within the committee members, and this very ambitious version, EcmaScript 4, was abandoned. Later on, some members of this committee forked basically the version 3 and created EcmaScript 5, which is what is essentially implemented in all modern browsers today. 2 years later, in 2011, there came a minor revision, 5.1, and this was at 258 pages of documents. So, however, after that, they started working on EcmaScript 6, and right now the final draft is ready. Only minor corrections are being added now, and it is expected that this June we will have the final version. And to give you and this is the most significant release since EcmaScript 3. To give you a comparison, EcmaScript 5 was around 250 pages, as I said before, and this new version is clocking at 657 pages. So it is the most significant revision yet. And since the technical committee members worked in Harmony as opposed to the fourth version, it was also nicknamed Harmony. At the same time, since EcmaScript 6 is already almost ready, work is being done on EcmaScript 7 at the same time, simultaneously. So there are different implementations of JavaScript from server side, as Patrick said, Node.js, IO.js. In client side, we have different browser implementations. And when we look at the compatibility table created by a famous JavaScript hacker called Kangax, here each column is a different implementation, and each row is a different feature in the specification. And if you look at this, you might see that most of the features are not supported by many implementations. However, recently there has been a transpiler project called Babel.js, which basically, if you look in the left-handmost column, you will see that most of the features are now implemented with this transpiler. And the beauty of this transpiler is that it generates codes that can run in any browser or in any server-side environment today. So that means that actually most of the features in EcmaScript 6 are already usable by JavaScript developers, even though the draft is not finalized yet. So there are a lot of features, so I won't go over all of the details. So these will be the basic sections we will be dealing with. First, I will introduce lexical variable scoping with let and const keywords instead of the var keyword we use for declaring variables. I will go over changes in functions. I will go over changes in objects and destructuring. I will go over the new class syntax. I will go over template strings, and finally, if time permits, promises and generators. So first, let and const. JavaScript as a language is very similar to Java or C in that it uses these curly braces for blocks. However, it has a major difference compared to Java or C. the variables we declare are function scoped, not block scoped. However, the newly introduced let and const keywords introduce variables that are block scoped. So let's see what the difference between var and let is. So here I have a var keyword in a for loop, okay, in a block, which is encapsulated in a foo function. Now what will this console log I output? What will this console log I output? Now JavaScript has a functionality called hoisting. Hoisting means taking it to a higher placement. Okay? So what the JavaScript interpreter behind the scenes does is it gets this var I and moves it until it sees a function statement or function expression. So actually, even if we have written var I, behind the scenes it works as if we have written var I here. This means that although we defined it here in this for loop block, I will be defined throughout the whole function. This is what we mean by function scoping. So you'll see that this I will be escaping through these curly braces. It will be escaping from this block. So this will log undefined. That is, it will not generate an error because I is defined as undefined value here. And here, at the end of the loop, even if we are out of the for loop, it will print 10. Okay? Now if we change var with let, we will be scoping this I variable inside this curly braces, inside this block. So this will output an error. And this will also output an error. Similarly, const. So with let, we define variables that can change over time. With const, we define constant variables, which are also block scoped. Okay? And usually, you should be preferring const if you know that the value is not going to change. And by default, assume that most of your variables won't be actually varying. Now let's go over changes in functions. The changes in functions can be summarized in 3 statements. So first, default parameters have been introduced. So while defining a function foo with an argument name, I can give itself a default value. For example, name is equal to Üstün. REST parameters have been added. Syntax for REST parameters have been added. So here I define a function foo. The first argument is name. The rest of the arguments, however many arguments we have, will be collected in an array, in a single array, and will be set equal to the rest argument. So if we hadn't written these 3 dots here, rest would be only equal to the second argument, right? Second input argument. The moment we write these 3 dots, rest will become equal to the arguments except the first, so it will be an array. Destructured parameters. So here, again I define a function foo, but it actually accepts a single parameter, single object. And here I'm indicating that I'm interested in the name fields and surname fields of the incoming argument. This might seem a little bit confusing, but we will see it with an example and you'll understand it better. So first with default parameters. For example, here I define a hello function. Name equals Üstün, greeting equals hello. So you'll see that if I don't pass anything for these arguments, they will get these default values. However, if I pass, for example, here I say hello Ahmet. So this means I'm overriding the default parameter, but I'm not overriding the default parameter for greeting. Or here, hello Mehmet Ola, right? Here I will be overriding both of the default arguments. Okay, so this is very straightforward. However, the only gotcha here is that these are not keyword arguments. So if you are used to languages like Python, which has Python keyword arguments, you might think that you might be able to do this. Like hello, greeting equals hello, name equals Özgür. Like swapping the order of the arguments. This is not possible. These are default arguments, not named arguments or keyword arguments. Now rest parameter. As all of you know, JavaScript functions have an arguments, array-like structure defined for every function. The number of arguments a function takes in JavaScript is not predefined. That is, you can pass any number of arguments to a JavaScript function and they will be collected in an array-like structure called arguments. However, notice that I emphasize that it is array-like. It is not a real array. So it will be lacking some methods like slice or some other methods that normal arrays have. To remedy this situation, we now have REST parameters. So REST parameters work with the ellipsis or three dot syntax, and basically they will be getting the rest of the arguments. For example, here we have a function called sum 15, 1, 2, 3. Okay? What I want to do is to collect these remaining arguments in a single array. For that, I define a function called sum. I get the first value as a normal argument. And then for the rest, I put dot, dot, dot. This means that the first value will be matched to 15. The rest of these, as a collection, as an array, will be set to the value rest. Okay? So then I can just, like a normal array, I can loop over it and add it to the total. Okay? Yes?
Sorry, rest is a keyword or you use your...
No, rest, yeah, rest is just a normal...
so you have to use the three dots?
Yes, the three dots are what's the syntax. The rest is just my name. I could call it the rest of the arguments, etc. Okay? Of course, this example gets the first number and adds the remaining arguments. So here, actually, I don't need this first value. So I could just have written it as just getting all of the arguments in the single parameter called rest, but for example, I just gave this version.
And you get, sorry.
Yes.
You can use more than one first parameter? Like
yes, you can use more than one first parameter, but you cannot use more than one rest parameter because then it will get confused.
So I can use first value,
second value, and then rest. Yes, exactly. But you cannot use two because it doesn't make sense. Now, I'll go over the other changes in function, but there's a similar operator to the rest operator called spread operator. It again uses ellipsis, dot, 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 but we'll see what it does. So here I have a function that accepts any number of arguments, okay? But it doesn't accept an array. So mathmax 1 to 3 outputs 3, as we expected. However, if I pass an array into this 1 to 3 array, I get a not a number error, or not a number result. Why? Because mathmax only operates on the whole arguments. That is, it doesn't accept an array. But I want this to be basically destructured. That is, I want this to be no longer an array. I want this to be passed as individual parameters, just like this. So what's the solution there? Like, could I assign it to a variable and then call math.max? Would that work? No, because this is essentially the same, right? So the way to solve it is to use apply. What apply does is, here I'm giving you arguments in the form of an array. Okay? So this essentially amounts to this math apply. Again, I just say, I have to say math here, and then I say a. This essentially amounts to this. Okay? This structures into this. But as you can see, this is kind of clumsy, right? Because we have to call math twice, and it's longer. One trick you can use to remember that is, apply starts with a, and here again I'm passing arguments. It also starts with a, so apply arguments. So that's a nice trick to remember how apply works. Apply applies the arguments as an array. Okay? However, instead of using this cumbersome notation, now I can use dot 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 operator. Okay? Math.max dot dot dot. So this basically works like a spreading operation. So think of like spreading Nutella on a loaf of bread, right? Here what you are doing is getting this array, like Nutella, and spreading it inside the function call. Okay, so this is very similar to the REST arguments, but in the other direction. This is while calling. REST arguments is while defining the function. Okay. Now parameter destructuring. Now usually JavaScript functions get an options input argument. However, this options argument is an object, and we are interested in some fields. For example, here I pass a name and options, and options has a language field. So I check if language is English, I say greeting is hello. If language is S, I say greeting is hola. Okay? Now this options is basically a huge bag, and without reading the function itself, we cannot know which fields we are interested in. Now, here comes a solution EcmaScript 6 provides. While defining this hello function, we say that we are expecting an object here whose lang or lang key we are interested in. So this essentially does the following. It gets this option input argument, it gets its language lang key, and it essentially sets it to a lang variable. So instead of this, we can just write this. While calling this, we will still be passing an object. We won't be passing just English. We will be still passing language equals English or language equals Spanish. Okay? But here, to some maintainer of the same code, reading like 5 months later, he can just by looking at this see that this function accepts an options object that has a language field in it. But here, without reading the function itself, he cannot see the same information, and also it's much longer. So this is what the destructuring basically means. It gets an object, it destructures the keys and values, and it assigns them to some variables. Okay, so any questions here? This might be a bit hard to comprehend on first. Yes?
Can be, in this situation, can we use a default argument? For example, lang equals English.
Good question. I think no, but I haven't tried that. Like I haven't tried mixing default arguments with here, but probably. Yes?
What about modifying the contents of line?
Yeah, you can do it. It's just a variable.
It's a variable.
Like just like you can modify name, you can modify lang. It's just a normal function, a variable. Okay, so for example, another example. Let's say we have a setCookie function. Again, like very common situation with JavaScript libraries. It has an options argument as the last argument, and options.secure, options.path, domain expires. So this is the first version. So we call it like setCookie, secure true, expires some number, right? And this is the second version, setCookie, name value. These are the first two arguments, and here curly braces secure path domain expires. So it means get the third argument, destructure it, so that we get the secure path domain and expires fields, and rename them to normal variables in our code. And this is much more shorter. Now,
what happens to the stuff that you don't pass, like especially path and domain in this case?
Yeah, they are set to undefined. So basically, you can think of your what this is basically doing. Okay, so this is in a way pattern matching but loose. That is, it's not very strict. If you don't pass anything, it will be undefined. Yes.
Can you nest objects? Can you do options, language, or something else?
Yes, you can do nested destructuring. So it's very powerful. Now arrow functions. Now instead of function, a, b, return, etc., there is a new syntax for defining functions. So you just use the fat arrow equals greater than, ab goes to a plus b. So you'll see that function keyword is missing, curly braces are optional, return value is optional. So this is the same function, just written very shortly. Actually not the same, almost equivalent, and we'll see the difference shortly. But basically, this is a very succinct way of defining functions. So this is usually useful when you have short functions. For example, let's say I have a number array, and I want to find the even or odd numbers, right? So I would say numbers.filter, and I would pass a function here that checks for oddness. So here I can just type it as a lambda function or a short function. So it takes an x, it takes a modulus, and if it's 1, that is it's even, it's odd, it returns true. Or similarly, for example, I reduce them with this function. What does this function do? It takes 2 arguments, multiplies them. So effectively, this multiplies all the numbers in the array. Okay? So there's one simple difference between this syntax and the other function syntax, and that is because of the this keyword in JavaScript. So here I define an object, x, name üstün, I define an hello, and I call x.hello. And within the hello method, so this is a method, within the hello method, I define a helper function. I say name is this.name, and within hello method, I call this helper. Now if this were this.name instead of that.name, the moment I call helper, what would this refer to? Would it refer to the object x? No. The reason is I'm calling this helper function naked. That is, it is not bound to any method or object. It is called as a simple function. With functions, if it's called like a normal function, so here I'm calling it with the dot notation. So this is a method of invocation. Here, I'm calling it naked, like just a normal function. This means that here, this will be bound not to this, which is x, this will be bound to the global object. This is a common problem for JavaScript developers, and there are various ways of solving this. So one of the problems is that this keyword is a keyword, it's not a variable. So one solution is, here I convert that keyword to a variable by calling that equals this. So effectively I am freezing that to this. Okay? And then here I refer to that.name instead of this.name. Now I know that here, before calling the function, this refers to x, right? Therefore, when this is called, that will still refer to x. But I cannot say the same thing about this. Okay? So technically, this means that the keyword this is resolved at runtime, while that is resolved lexically. That is, while reading it, you don't have to run it in your mind. You know that is inside this x. So without running it, you can say that here refers to this x. Okay? So this is one of the solutions. But you can say that most of the JavaScript examples have that equals this trick. Another solution to this is to bind this function. Now I'm still calling it naked, but this time helper is not a naked function. It's a function that has immediately been bound. And this value has been frozen. Okay? So this is not a function whose this value can change anymore. The moment I call bind this, I'm saying whatever this refers to here, freeze it to whatever this is while I'm defining it. Okay? So this bind was introduced in EcmaScript 5. So this is another solution. And let's see the solution EcmaScript 6 provides with arrow functions. Basically, arrow functions do this binding automatically. So the moment we define a function, so this is a function that takes nothing and returns this console log. This is lexically bound, not dynamically bound. Okay? So here, I don't need any of those tricks. This will refer in an arrow function to whatever the value it was while it was being defined. Okay? So this This is the basic difference between arrow functions and normal functions.
Can you repeat?
Yes.
I lost it.
Yes. So normally, if I had a normal helper function, the value of this keyword would change according to how I call it. For example, I call helper without any method or object references, right? I call helper on its own. For example, here I call hello not on its own. I call x.hello. The moment I say x.hello, this means within hello, this is bound to x. But here I'm not saying x.helper.
Yeah, that's the global one.
Yeah. So here, this will refer to global. However, with arrow functions, it's as if I did this, binding. So with arrow functions, this will refer to as if I had a helper function here as a method of it, and I call it like x.hello, similarly. So here, could you tell me what this is here, outside this function? Like, the moment I enter this hello, the moment I enter hello, since hello is a method of x, this will refer to x. And I define helper now as an arrow function. Now I know that this is now bound to x. Since I define the arrow function, this will not change. The keyword this will still be referring to x. So all of these, that equals this. So here I'm basically setting a temporary variable that doesn't change. So I'm like saving it for.
Yeah, but you just do that with that keyword, like equal, parentheses, and all that.
Yes, I can do it like this already.
Yes, but
I can do it like this already.
Yeah.
Or I can do it like this with the new arrow function. So here I don't.
That's all you have to do.
Yeah, that's all I have to do. So this is just some convenience. Like, it's not like this couldn't be done before, but more like it's now easier.
Yeah.
Yeah.
It's like a shortcut. Or something.
Yeah, just a shortcut. Yeah, exactly. Like no return keyword, no function keyword, no binding of this. These are all automatic. Okay, now let's go into changes in objects. Again, some kind of destructuring is possible with objects. We have already seen destructuring in function arguments. So here I have an object, name üstün, last name Özgür. And here, on the left-hand side, basically I match left-hand side to the right-hand side. So here, instead of saying var x is this, I say var curly braces, name, last name. So now, here it does pattern matching. That is, think of matching the left-hand side to the right-hand side. On the left-hand side, I have name. On the right-hand side, I have name equals üstün. So what will name equal to on the left-hand side? Üstün. So effectively, this is doing what we would manually do with name equals üstün dot name, last name equals üstün dot last name. Yes?
Do you have any info on the performance spec of this?
Performance.
Performance specifications, if this is like the same speed as the one before.
Yeah, with performance, actually I'm using Babel.js. And what Babel.js is, I write this, it converts it to this.
Okay.
So it should be essentially equivalent. Okay? So again, like while learning this, you have to think like how would you write it before and how you write it after. And after a while it becomes natural. Okay? So basically this, what Babel.js generates is, it saves it into a temporary variable called x. It says name equals x.name. Last name equals x.last name. Okay? And this thing is basically called destructuring because it takes a right-hand side, which is structured, destructures it, and rebinds it. And again, it is loose. That is, for example, if on the right-hand side this had an ID field, it wouldn't affect the left-hand side. Or similarly, if the right-hand side didn't have the last name field, simply this last name would be set to undefined. Okay? So this is, yes?
How does this look with the nested objects?
Yes, very good question. So with nested objects, you can also do destructuring. So for example, if you have an address field here that has a city field here, here on the left-hand side, you can basically mirror the same structure like address, city, and it will match including the city.
So you would get define both, like address and city?
Yeah, address and city. Yeah, I have an example, if time permits, I can show. And also, like, you don't need to get the same thing. For example, instead of name, you can say number. So this means take name from Üstün, set it to a local variable called number. But this is usually not common, like you usually get whatever is on the right hand side. But it is possible to change the name. So it would be equal to say var number equals Üstün.name. You can also destructure arrays. So var square brackets a, b, 1, 2. This means match the right hand side to the left hand side. So a becomes 1, b becomes 2. So for example, the swap operation in JavaScript, var ab becomes ba. Very simple operation. And again, this, as I answered before, deep destructuring is possible. Now there's a shorthand for object creation. So let's say I have the following variables: age, 30, name, Üstün, location, Ankara. Okay? So a common thing we do in JavaScript is say name equals name, age equals age, location equals location, right? EcmaScript 6 committee saw that as very common and therefore decided on a new syntax for defining like this is a reverse destruction. You can think of it like reverse destructuring, right? So if you write curly name, age, location, this is basically equal to repeating this name, name, age, location, location. So this is the shorthand for object creation. Again, while defining objects, you define functions. Now, if you know that there are parentheses, you already know it's a function, so you no longer need to write function here. So you can say name is the same name, parentheses, and you'll define the function. Another thing, template strings. So normally we have variables in our code and we do string concatenation if you don't use a template library. So like I'm plus name plus my age is plus age, right? So this can be hard to read. So there is now new syntax for new template strings. So you use the backcode to start a template string, backcode to end it. And here, with the $sign, you can refer to variables or expressions outside. So you can say I'm $name, my age $age. So it will basically go and use this for the template.
One question. Is there any kind of two-way data binding?
No, not two-way. This is just template single-way processing. Okay? So it's like an email newsletter, like you have the template, you have the variables, you combine them. Very straightforward stuff. And also one more thing, you can also create multiple lines here. So normally with JavaScript, it was not possible to do multiple lines. Now you can use multiple lines. One small addition, or actually big addition, is actually with template strings. Before the template string, you can write a function name here. So what function name will do is, it has the following interface: literals, variables, and you can basically process your template string. For example, let's say if you write a function that will only uppercase your static parts of your template, or that will only uppercase or lowercase your variable parts. So what I mean by static parts and variable parts is this. So here hello is static, right? So name is variable. So I can pass it through a save function, which I myself define. And within the save function, I can, for example, URL encode the variables so that I'm resilient to XSS attacks, etc. Or for example, I define an uppercase function and I define it as like uppercase hello name. So here I'm not uppercasing the whole thing, I'm just uppercasing the variable part. So this is called tagged template strings. So you have the template strings, but you are processing it through a function. Class keyword. So this was one of the most famous additions to the language because, as you all know, JavaScript is prototypal based. Although it's object oriented, it doesn't have classes. So finally we have class keyword. Behind the scenes, actually it becomes like prototypal inheritance still, but we can now use class and extends keywords and super keyword just like we use in Java.
Interruption. Officially, your time is over. Should we continue with that? Are you all like good with that? Yes. Interested? Okay, cool.
Yeah. Okay. Yeah, I mean, not much left if we don't include promises and generators.
That's what I'm asking.
Yeah. So here I have a class human. I define the constructor with the constructor keyword. It gets two input variables, name and age, and I say this dot name equals name, this dot date dot age is equal to age, okay? And here I define a student class that extends human, with very familiar keywords if you are familiar. So here, inside the constructor, I call super name age. So since the super class is human, it will call this constructor, name and age, and then I will set school to school. But this is very straightforward. If you want to use class keyword syntax, you can now use it. So there are some other features like modules. There is now syntax for modules so that your files can be interlinked. We were already using this in Node.js with require statements, but now we will be able to use it in the standard. So this is just syntax. It is up to the implementation as to how to implement it. So most of the time you will still be using some transpiling tools, or if you are using Node.js, not much will change. So, but it's now in standard. There are two more important additions, but I won't go much into them for now. I think I can go more detailed into them after the second talk, because I assume that the second talk will also cover promises and generators, so I don't want to spoil the second talk too much. But after the second talk we can also discuss promises and generators. But these are the biggest additions I think for ECMAScript 6, but these are a bit harder to introduce in a single topic. So all of these examples I have shown you are usable both client-side and server-side, whether you are using IO.js or Node.js through the Babel transpiler. So Node.js is actually tracking IO.js several versions behind. IO.js uses the newer V8 engine, and some features in Node.js are missing from. So some Node.js lacks some of the features, but if you use Babel.js and transform your code before running, you will get all of these features now. So in order to do that, you install the Babel library, you require this Babel register, and anything you require from now on will be first processed through Babel automatically. So there are two approaches here. You can pre-process all of your files using Babel, like Babel source to destination, or Babel with the experimental flag. So some of the things I have shown are experimental. Or you can use Babel register, and the moment you require some file that contains any of these, Babel will first pre-process it for you. So behind the scenes, it basically does the conversions I have already shown you. So if you want to get deeper into ECMAScript 6, there is a very nice freely available online book called Understanding ECMAScript 6. And the Babel.js site is very helpful. And also you can find the specification at this file. And thank you very much. You can find the slides here at my GitHub repository. And I will also be giving a React.js workshop in Copenhagen in May, so if you are interested in React.js, you are free to come. Actually, it's not free. You are welcome. So I think that's all until we end the second talk and we talk about some promises and generator stuff. Thank you very much.
Thank you.